Hello, let's continue with our lesson. Today we will talk about M2 Chapter 1 Projectiles, Examples 5 and 6 on your notes. Now, in the previous lessons, we have talked about what projectiles are. Okay, the projection would give you a speed, initial speed at an angle, and they will tell you an angle. And we are also familiar with resolving into the X and Y direction. We also should think about the different direction that the projection can vary, for example, horizontal, downwards, or the most basic, upwards. Then, we're also reminded we should use the Subet formulas from M1, but in the separate components to solve questions in projectiles. Let us go to example 5. Example 5. A ball is thrown from a point O on a horizontal ground with speed u meters per second at an angle of elevation of theta, where tangent theta is 3/4. The ball strikes a vertical wall which is 20 meters from O at a point which is 3 meters above the ground. Find the value of u. Find the time from the instant the ball is thrown to the instant it strikes the wall. Let us go back to our paper. Okay, so I'm going to start drawing. At the same time, read the question while drawing. A ball is thrown from a point O, horizontal ground. Please use a ruler if you can help it. Okay, with speed u, this is a number, not a vector. Angle of elevation theta, where tangent theta is 3/4. Right? The ball strikes a vertical wall which is 20 meters from O and 3 meters above the ground. So this is how the picture looks like. Now let us work on this trigo. We do not need to find out the exact theta. We just need to figure this out in the trigo ratio. So I will draw a right angle triangle similar to the diagram. Tangent. So this side would be 5, right? As such, our ratios for sine theta should be 3/5 and cosine theta would be 4/5. This is like our preparation work. We should also resolve the velocity. So horizontal component, ux equals to u cosine theta. If we substitute in the value, you should get 4/5 u. Okay, if you resolve vertically, uy is u sine theta. You substitute again, you will get 3/5 u from our basic formula. Remember? Okay, now let's start the question that we need to answer. Find the value of u, part A, 5A. So if we do horizontal direction, we can use, let's quote the formula we're going to use. The formula, distance is speed times time. Okay, the horizontal distance is 20. The horizontal speed is 4/5 u. And we do not know the time. All right. that should give us t is equals to 20 times 5 over 4u, which is 25 over 4u. I'm sorry, 25 over u. I've cancelled it. Okay, and then we can't really do anything about this to find the u. Let's do the vertical direction. Tell them I'm doing vertical as positive, upwards positive. Tell them the formula I'm going to use. I'm going to use that. S equals to ut plus half at squared. Okay, because I'm going to try to use this 3 meters, which is the vertical distance, so 3. Vertical speed, 3 over 5u. The time is unknown, plus half a. A is gravity. Gravity acts downwards, and g is equals to 9.8. So when it's downwards, we should put in negative 9.8 and t squared. Sorry, let me move this up. Okay, I'm going to substitute this t equals to 25 over u, but for formality on working, let me call this equation 1 and say substitute t equals 25 over u into 1. And let's just write down 3 equals to 3/5 ut minus 4.9 t squared. So 25 over u, 25 over u. All right, then the rest is algebraic manipulation. Yeah, is positive. So 16.0. Okay. Let's go on. So now that we have u, and we also know that t is 25 over u, so we can easily find the t required in part B. Like this. You should use the calculator value or the answer button for the 15.975. okay, for your working. Next, let us go to question 6. Okay, example 6 is a little bit different. Let us read it first time. A stone is thrown from a point A with speed 30 meters per second at an angle 15 degrees. Sorry, there's a typo error, 15 degrees below the horizontal. The point A is 14 meters above the horizontal ground. The stone strikes the ground at point B. Find the time the stone takes to travel from A to B, and then find distance AB. Let's go back to the paper. Sorry, the wrong one. Okay, example 6. I'll read one more time at the same time I'll be drawing. The stone is thrown from point A with speed 30 at an angle 15, not very accurate, 15 degrees below. Okay, take note, this is below the horizontal. Right. The point A is 14 meters above the ground. And then if you throw at an angle, it will follow a projectile, it's a curve, and hit the ground at point B. Basically, this is the picture, and this is 30 meters per second. All right. Now we're supposed to find the time the stone will take. So like last time, before you know and start to think too much about what you want to do, you can do some preparation. So you write UX and you write down UY for use later. So UX is U cosine 15. And UY is, sorry, I should put in the 30. 30 cosine 15 degrees. Multitasking. The formula and then the numbers. If you can directly write, that's fine. U sine theta 30 sine 15. You can press the calculator or can leave this like this way because it will be more accurate. Okay, now let's start. So we want to find the time taken, and the time taken in this time, the general direction is vertically down and horizontally to the right. Okay, since I know the horizontal distance traveled would be 14, I can set downwards as positive. Okay, then I would know that my U will be 30 sine 15. My S will be 14 because down is positive, right? And A is 0. And my A will be g, which is 9.8. Since down is positive, g is also positive. And we want to find t. It's good to write these kind of things on your question paper as you read the question, and it will help you decide which SUVET formula you want to use. So in this case, I want to use S equals to UT plus half AT squared. I quote it, write it down first, then I sub in everything and show them I know where each of the parts go. Okay. I miss out a T, sorry. Like this. Okay, then we will end up having to solve a quadratic equation. When you use quadratic formula, you should try to quote it. You can quote the whole thing in unknown, or you can show where you substitute. So it's minus b squared minus 4ac whole thing over 2a, like this. Okay, I've only taken the positive because time is positive, so I will make a remark in my next line. 1.074 something. Yes, AT is. Or you can give two answers and reject the negative. Final answer, I try to keep to 3SF. Okay, so this is the time taken from A to B. It's 1.07 seconds. Okay, part B requires us to find the distance AB. You first need to know which AB we want you to find. Now we are given the vertical distance. We are not given the range, but we can find if we need to. And the question asks us for AB. So you need to know that we're asking for this. This distance. You get it? So you should be aware that we are likely to use Pythagoras theorem, and we need to find the horizontal distance traveled. Okay, now B. Let us do in the horizontal direction. And if I want to find horizontal distance, I can do distance equals to speed times time again. The time we have gotten from the previous part, 1.07, you should use the exact form in your calculator. So 30 cos 15 degrees times 1.074 something 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 should get 31.136 something. Okay, this is this distance here. All right, let me draw it out. This is B, this is A, this is 14, this is 31.136, this is right angle. So by Pythagoras theorem, AB squared would be 14 squared plus 31.136 squared. You should use the calculator for the more exact answer. Write it down, and you should get something like 34.138 meters. Sorry, wasn't aware it's not there. Okay, and the question is done. Okay, we can discuss in class if you have questions.